All right, so here's some more notes on figuring out the equation for tile arrangements and the nth term. So it says, what is the 20th term for the following tile arrangement? Okay, so we don't actually have the tiles to move around, but we have the tile sketches right there. All right, we know that the place in the pattern is the X or input or domain. Without knowing where in the pattern I place the sketch or the tiles, I don't know how many, which again is my Y or output or range. So we know this is my first sketch, second sketch, third sketch, fourth sketch. Okay, I know that in this sketch there are 5 tiles. In this sketch there are 9. In this sketch there are 13. In this sketch there are 17. So what I can do is I can use this X input to get the Y output and actually make a table if I want. Okay, we know that to write an equation I have to find slope. Slope is the difference between the Y's, so that's going to be a positive 4, positive 4. So my pattern there is plus 4. I know that I'm counting by ones up here, so my rise over run is 4 over 1, which is then obviously 4. So my slope is 4. Okay, now to find the y-intercept. I know that's when x is 0, so that's at the very beginning. So if I go back up to my tile sketches, what did I have to begin with? Okay, it's like that problem I keep telling you about. Let's say the little Julie, she's babysitting. She wants to buy a pair of boots for $200. Okay, she's going to get $10 per hour, but her parents are so proud of her for wanting to earn the money on her own that they give her $25 to start. That would be your y-intercept. So here we need, that's my 0. Well, let's go down to our pattern then. If I'm adding 4 going this direction, then I simply have to do the opposite going back. So I'm going to subtract 4 from 5, so my y-intercept will be 1. If I know my slope and intercept, obviously I can write an equation like we've been doing now for a week. So y equals, my slope is 4, and my y-intercept is 1. Now I can find the x-intercept by substituting 0 for y. Remember our little visual for intercepts? Make your function table. When x is 0, that's my y-intercept. When y is 0, that's my x-intercept. So 0 equals 4x plus 1. Okay, let's get the x by itself, so let's do the opposite. They cancel. Left with negative 1 equals 4x. Okay, go ahead and divide by 4. Divide by 4, they cancel. So x equals negative 1/4. Now, if you had a graph, you would have never seen that because that wouldn't have been at an intersection where you can identify it. So the x-intercept is negative 1/4. So you have to be able to calculate x-intercept mathematically. So now I need to find the 20th term. Okay, here's my equation, so I can extrapolate. Remember the word we talked about today? So I'm going to go ahead and substitute 20 in for the x. And I can do this in my head. You should be able to as well. 4 times 20 is 80. 80 plus 1 is 81. The 20th term will have 81. So if we look back at our tile sketches, we see here that looks like I'm adding a row each time. Now, if this is our first term, look, I guess it's column, 1 column. Here's our second term, 2 columns. Third term, 3 columns. So what stayed the same each time? That stayed the same every time. The columns are what changed, and by 4. So here, then we had 2 of them. Then we had 3 of them. Then we had 4 of them. So the 20th one would obviously have 20 of those columns, and there'd be 4 in each one. So I'd have 1, 2, 3, etc., out to 20. So there'd be 20 of those. Each one would have 4. And then I'd have this 1 by itself. So 20 columns, each one has 4. 20 times 4 is 80. And then I have my last one right here. So 80 plus 1 is 81, which of course we already knew by doing it mathematically. So notice how my equation matches my picture. 20 columns, each one had 4, right there, and then I added 1, right there. Okay, so tomorrow you're going to be doing some of these without my help, and you're going to have to try to use the tiles first. And if you use these as notes, you'll have no problem. Good work.